So the next question is example 8.6. An inverting operational amplifier is to operate according to the following specification. Voltage gain is equal to 100. Okay. So let me write given voltage gain AV is equal to 100. Input resistance Rin is equal to, what is the value? 10 kilo ohm. Then lower cutoff frequency, if I take this as F1 is equal to 250 Hertz. Upper cutoff frequency F2 is equal to 15 kilohertz. Devise a circuit to satisfy the above specification using an op-amp. Okay, so since the two cutoff frequency is given, the circuit will be the inclusion of a capacitors, right? Inclusion of the two capacitors across the input as well as across the feedback. So first we have to draw the circuit. So you have to find out the values of the parameters in the circuit. So let us draw the circuit. So the clue given in your question is it is an inverting op-amp. So the input is applied to the inverting terminal. So if I take this as V in, okay. So we are applying, since your cutoff frequency is given, we are going to add your capacitor C in. This will be your resistor R in. Feedback, okay. This will be your RF upper cutoff frequency, so you will be getting a CF here, okay, right. So this is inverting terminal, this will be your non-inverting terminal will be grounded, okay. So now you have to find out the values of the appropriate parameters. For all the values you have to find out, that is called as device circuit or design, okay. Okay, so let us start with any direct answer is given. Yeah, R in is given, the mid band, right? So what will be its corresponding diagram? Frequency response. So if I take this as AV, so this is frequency in hertz, you will be getting both cutoff frequency, right? So this will be your AV max. So 0.70%. So 0.707 AV max will be your two cutoff frequency F1 and F2, where F1 is your lower cutoff frequency. What is the formula given? F1 is equal to 1 by 2 pi C in R in. Similarly, F2 is equal to 1 by 2 pi CF RF. Okay, these are the two formulas. Okay, this will be your mid band. Bandwidth will be equal to F2 minus F1. These are the various parameters. Now can we proceed with finding out the values? So we know that R in is equal to, as it is given, so 10 kilo ohm. So one parameter is already, you have got the one parameter. Let me write towards here. So 10 kilo ohm. So what is left back? We have to find out C in, RF and CF. Now can we find out RF? So second is to find RF. Okay, so it's an inverting amplifier and your voltage gain is given, AV is given. So what is your, in order to find out the RF, it is enough to take the magnitude. Okay, so AV is equal to, for inverting amplifier, it is RF divided by R1, right? So AV is given, R1 we have found out. Now can we find out RF? RF is equal to AV into R1. So what is your AV? AV is equal to 100 into R1 is equal to 10 kilo ohm. So RF will be equal to 1000 kilo ohm. Okay. So we have now got your second value. So RF is equal to 1000 kilo ohm. Okay. Now we are moving on to the third parameter. So now our aim is to find out the values of two capacitors. So to find C in. So to find C in, what is the value we have to, or formula we have to use? F1 is equal to 1 by 2 pi C in R in, right? Now can we simplify this? What is 1 by 2 pi value? So 2 into pi is equal to, okay, 1 divided by answer is equal to 0.159. Okay, so 0.159 divided by C in R in. Now what is given in your question? lower cutoff frequency F1 is given, right? So F1 is equal to 250 Hertz. So 250 Hertz is equal to 0.159 divided by C in you have to find out. R in you have calculated. What is your R in? 10 kilo ohm. So 10 kilo ohm. Therefore, what will be your C in? C in will be equal to 0.159 divided by 250 into 10 kilo ohm. Okay. So here you have K. Here you have 1, 2, 3. So can I write it as 0.159, 0.159 250 into 10 into 10 raised to 3, right? 1, 2, 3. So can I write it as 0.159 divided by, so here you have 10 raised to 3, 10 raised to 4, 10 raised to 5, 10 raised to 6. So 2.5 into 10 raised to 6, right? So what will be the value now? 0.159 divided by 2.5 is equal to 0.0636 into, if I take this 10 raised to 6 to the top, you will be getting it as 10 raised to minus 6. So if we convert it into picofarad, you have to shift 3 points here, right? So 63.6 into 10 raised to minus 9 farad, which is equal to 63.6 nanofarad. Okay, so this will be your C in. Now the last value, so let me write C in is equal to 63 nanofarad. Now only one value is remaining, that is to find out the value for CF. To find CF, so CF, same formula, F2 is equal to 1 by 2 pi. So I can write it as 0.159 into CF into RF. So what is your F2 value? F2 is equal to 15 kilohertz, which is equal to 0.159 divided by CF into RF is equal to 1000 kilo ohm, which is equal to, so CF is equal to 0.159 divided by 15 into 10 raised to 3 into 1000 into K. So you will be getting 10 raised to 6, right? So which is equal to 0.159 divided by 15 into 10 raised to 9. Okay. So what is the answer now? 0.159 divided by 15, which is equal to 0.0106 into 10 raised to minus 9. Okay. So nanofarad. So I can write it as 0.106 into 10 raised to minus 9, which is nothing but equal to nanofarad. CF